Hey, fellow mathers, welcome to the podcast where math is figure-outable. I'm Pam, a former mimicker turned mather.
And I'm Kim, a reasoner who now knows how to share her thinking with others. At Math is Figure-Outable, we are on a mission to improve math teaching.
Y'all, algorithms are super cool achievements, but they're terrible teaching tools because mimicking step-by-step procedures actually traps students into using less sophisticated reasoning than the problems are intended to develop and use.
In this podcast, we help you teach math, building relationships with your students and grappling with mathematical relationships.
We invite you to join us to make math more figure-outable. Dum-dum.
Hi there.
Hey there. It's a day.
It is.
Should we record a podcast? Let's record a podcast.
We should do a podcast, and we should do some math.
Let's do some math. It's been a minute since we've done some. No, have we done? I don't even know. Let's do some math.
Okay. All right. So
cool.
we're going to do a problem string today. Yeah.
Uh-huh.
And sometimes we get asked questions about problem strings and what they should look like at different grade levels. Mm-hmm. Particularly when you do a problem string with adults and they ask questions like, what would that look like in my classroom? Like that doesn't
Especially
feel like it.
Sorry.
Yeah, go ahead.
Especially when it's a large grade range.
Yes.
So if I'm like working with fourth grade teachers, I'm probably going to do, I might do an adultish string and then talk about what it looks like in a fourth grade classroom.
Yeah, absolutely.
But if I got K-5 teachers, K-6, K-12 teachers in the room, that's a more detailed conversation.
Yeah.
Should we have that conversation today?
We should indeed.
Bam. Okay. So we're only going to do like a specific problem string, but I think there's some general things that we can kind of take away from if you've done this adultish problem string, what could it look like at different grade levels? So everybody, we're going to start with an adultish problem string, and then we'll kind of parse it out from there. So Kim, first question, again, I'm going to do this with adults. We'll talk later about who else I would do it with, but say I've got adults in the room, I might say, all right, y'all, first question we're going to do, not really hard. I wouldn't say not really hard. What would I say? First problem, here we go. 16 minus 10. All right, nobody's really thinking very hard on that one. 16 minus 10 is everybody. People will just call out, but go ahead and call out, Kim. 16 minus 10. 6. Then I'm going to say something like, hey, nobody needed to really draw anything, but mathematicians have mental maps in their heads. So I'm just going to go ahead and put a 16 on a number line, subtract 10, and land on 6. It's not a very long jump. It's just kind of there. We'll just kind of have it there. Mathematicians often have mental maps. Your mental map could have looked like this. Notice that I'm very careful to not say should have looked like this, must look like this. Like your mental map could have looked something like this. I'm also not saying thou shalt draw a number line right now in your notebooks, blah, blah, blah. Okay, next problem. 16 minus 9. A lot 7. Of you guys are, thank you, 7. I might say a lot of you guys are smiling. Did anybody use, maybe some of you just know that one, but Kim, did you use the problem before it? Maybe you just know that one, but could you use the problem before it to solve that one?
Sure. Uh-huh. Yep. So if I subtracted 10 before and got 6, now I'm subtracting only 9. So the answer is going to be one more.
One more. And so then I would draw the 16 minus 10 again, landing on 6. And then you're like, but it has to be one more. So then I make a little jump up of 1, landing on that 7. Cool. Next problem. How about 37 minus 20? Again, not going to wait very long on that one. Kim, what'd you get?
17.
17. So I'm going to draw a number line a little shifted to the right. I'm going to do 37, and then I'm going to say out loud, bigger jump of 20. Try to make it about twice as big as that smaller jump of 10. And you said land on 17. Cool, next problem. How about 37 minus 19? A lot of you guys are smiling. Okay, Kim, did you use the problem before to help you? Could you talk about that?
Sure. So if you subtracted 20 before, that got you 17. Now you're subtracting a little bit less, 1 less. So the answer is 1 more.
And I might at some point do a little bit of talking about, wait, we're subtracting, so why are you going the other way? And especially if a lot of people are like, wait, shouldn't you go back? I might say, did anybody get another answer? And if somebody says 16, then I might be, like, well, I subtracted that nice number, but then we were subtracting, I kept going. So I might have more conversation in there. For today, we're just going to be like, yep, you subtracted. You said it so nicely, Kim. We subtracted less, so we have to adjust up. Okay, cool. Next problem. What if I had 462 subtract 100? Mm-hmm. Okay, go ahead.
362.
And again, on that one, I'm not going to wait very long. I'm going to go over to the right. I'm going to do 462, and I'm going to do a bigger jump than I've done before, but I really don't have enough room to, so I might do a ... in the middle of that jump because I can't really do Not on my paper, I won't have enough room. Maybe on the board I would have enough room, but much bigger jump, minus 100. You said that was 3. I'm going to land on 362. Next problem. And now at this point with adults, I might say, anybody want to guess the next problem and I might wait and kind of see what but then I never let them say it. I might just say, want to guess? But I don't let them say it. And then I go, it actually is 462 minus 95. And I'm hoping people have I asked that guess question because anybody who's ready at this point gets a chance to look back at the pattern and say, okay, it was minus 9. It was minus 19. Ha, I bet this is minus 99. And then I get to go 95. And it's just enough of a little bit of a ping, a little bit of a zing maybe, where they get to go, oh, okay. Gives me a chance to kind of smile at them. And it doesn't feel too rote. It doesn't feel to mimic everything I'm doing kind of thing. All right, Kim. So all that talking, what's 462 minus 95?
This time I can subtract 100 and then add 5 back. So subtract 100 is 362 and then plus 5 more is 367.
Nice. At this point, I'll make a choice. I could still do another number line, do the first problem and then add on, or I might at this point just use the 462 minus 100 and just tack on that plus 5, because really you kind of see both problems in that one number line. It depends on how experienced the people are I'm working with, not really what grade level they teach. It's more if they've been thinking about numbers and using relationships. I might now just use the one number line or redraw the number line again. Does that make sense? I feel like I'm okay, cool. So you said it was 367. I hadn't written that down, so now I'm writing it down. Okay, next problem. Now again, depending on the experience level, I might at this point say, everybody look at the problems that we have so far. I kind of gave you a helper, 16 minus 10 to do 16 minus 9. I kind of gave you a helper, 37 minus 20, that many of you use to do 37 minus 19. I gave you a helper, and I'm kind of putting arrows by these. I'm kind of pointing to them. I gave you 462 minus 100 that many of you use to help you think about 462 minus 95. I wonder if you could use the patterns that you're seeing. What if I don't give you the helper? Could you create your own helper? What if the problem was 6,371 minus 1,988? Wonder if you could use the same kind of pattern that we've been using. What would the helper be? Now, I'm going to give people time. I might even have them turn and talk. Kim, if you were going to use the same sort of pattern, what might be that helper be for 6,371 minus 1,988?
I would prefer to subtract 2,000.
Look, you didn't even say the 6,371. Now, I might go find somebody that has that. Pretty much, if I've asked for that, I'm pretty sure I'm going to have people that have found that. Depending on the experience level, I might just give that helper problem. I might just say, here's the next problem, 6,371 minus 2,000, and then I would give the next one. Kim, how could you solve that second problem, 6,371 minus 1,988?
Yeah, I'm going to subtract 2,000 to get 4,371. But I know that 1,988 is 12 less. So I only want to subtract 12 less than I just subtracted. So I need to add the 12 back on. So if I was at 4,371 when I subtracted 2,000, I'm going to add 12 back, and that is 4,383.
Nice. At that point, I might have kids turn and talk. How did you create the helper? How does that relate to this problem? Why the 12? Bam. At this point with adults, I'm pretty, well, it depends. If we're having pretty good success at this point, I probably won't give the helper again.
Yeah.
If we're not, people are really struggling, I'm probably giving the helper. Yeah. For the podcast, I'm not going to give the helper. So looking back, what kind of helper could you write for 5.2 or 5 2/10, subtract 1.9 or 1 9/10?
I'm going to prefer to subtract 2.
All right. So 5.2 minus 2, which is
3.2.
Okay. And how does that help you with?
Yep. I subtracted too much by a 10th. So I'm going to add a 10th back on and get 3.3.
And again, I'm drawing the number lines. We're shifting, not shifting. We're adding up to make up the difference. Cool. So it looks like and I want to start putting generalization words to it. It looks like you can subtract a bit too much and add the extra or add back in the extra because you subtracted too much with whole numbers, with thousands, and with decimals. Check it out. But I mean, maybe only tenths. I don't know if you can do it with hundreds. Like, what if I gave you something like 2 and 63 hundredths minus 97 hundredths, or 2.63 minus 0.97?
Mm-hmm. It's like 97 cents. So I'd rather subtract $1
Okay.
to get $1.63, 1
Mm-hmm.
and 63 hundredths. And then I subtracted 3 cents too much. So I'm going to add that back on and get 1 and 66 hundredths.
Nice. Cool. But we can't do that with fractions. That'd be crazy.
Mm-hmm.
I mean, let's try it. What if we had the problem 19 and 1/3?
Mm-hmm.
Actually, let me just say, since I'm kind of talking about how I would do this, fractions is the one that I might just give the helper problem, no matter how well it's going. Especially if I'm working with elementary teachers. It's not a dog on elementary teachers. They just deal with fractions as locations on number lines a little bit less. So let's go ahead and do the helper problem on the podcast. So 19 and 1/3 minus 8.
Okay.
What do you got?
That's 11 and 1/3.
Okay. So I'm drawing a number line. I'm putting 19 and 1/3 in a location. I'm subtracting 8. It's 11 and 1/3. We now have that landing space. I'm aware, Kim, that if, please no one look at my iPad right now, because that jump of 8 is as big as the jump of 100.
Nice.
So I might, I want to maybe say something to kids of like, obviously these lengths are not all proportional. Okay, next problem. I'm definitely going to ask at this point, anybody want to guess the next problem? Kim, do you want to guess? Do you want to guess out loud?
Well, you have thirds in your previous problem, 19 and 1/3. So I'm going to guess that you are doing 1/3 less or 2/3 less than 8.
Yep, it is 19 and 1/3 minus 7 and 2/3.
Okay. So since I'm subtracting, when I did 8, subtract 8, it was 11 and 1/3. Now we're subtracting 1/3 less. Then I'm going to add 1/3 back. So that's 11 and 2/3.
So you just did subtracting of mixed numbers with kind of some craziness, where some people would say you had to borrow. Mm-hmm. And you're like, nah, I'm just going to subtract 8 and then add back in that third. And you ended up having to do 11 and 1/3 plus 1/3. Mm-hmm. Not shabby.
Not
cool.
Shabby. Fantastic.
So we would end that problem string with having kids talk about, what were we doing every time? Why in all these number lines do we have this big jump and then this little jump back and this big jump and then this little jump back, and like get some words going around that. Yeah. And we're developing the subtraction over strategy. Subtract a little over, add back in what the too much that you subtracted. Cool. Yeah.
Which is a great strategy to develop when you have a wide grade range, because it's a strategy that applies pretty much at every single grade level. So they can find themselves in it. So when you do adultish strings, they often start with some small numbers. We did 16 minus 10, 16 minus 9. And then they range often all the way up to decimals and fractions. So let's talk about why you do that with adults. One of the things is that what I've noticed is that when you start a problem string, you start with something small and like the tension in the room goes down. Like people just like relax into it, like, oh, okay. And so they get a chance to feel the strategy with smaller numbers. Mm-hmm. You're not going new strategy you've never seen before, really big numbers.
Big, crazy, or complicated numbers. Yeah.
Yeah. Mm-hmm. Yeah. Mm-hmm. Also, I kind of just alluded to that they can see how the strategy applies in a variety of grades. So it kind of gives some weight to a strategy to say, like, hang on a second, we can do this work in like first grade and in fifth grade and in high school. So that, it demonstrates what a great strategy that it is. Mm-hmm. And a thing to note about your adultish problem strings is that we just did a lot of problems.
Yeah.
There are quite a few problems. But that's specifically because you are with adults.
14. And I just counted 14 problems.
Yeah, that's not a recommendation to do that particular string in its entirety in a classroom. It's you kind of have a different point, I think, when you're doing these strings with adults in a workshop. Yeah, so you can get a lot more in faster because maybe you're working with adults, but you also want them to see the stretch that can happen.
Mm-hmm. Yeah, nice.
So sometimes people ask about strings for their particular grade level, or in a workshop they would say, what of this would you do with fourth grade kids? What of this would you do with like second graders? Like this string wouldn't be good for second graders. It has decimals and fractions. So we thought we would talk about this particular operation, subtraction, and this particular strategy, the over strategy, and name out loud what we might do for different grade levels. So When
Nice.
you're sharing, let's talk about which problems we would keep and why, and then maybe what we would add in for a particular grade level.
Yeah, I love it. So let's say that, well, I'll just say that we believe this is a good strategy for first grade and up.
Yeah.
Like intentionally teaching it. Now, maybe you got some kids in kindergarten that are ready for it, but first grade. So I would keep the first problem in first grade, 16 minus 10, 16 minus 9. I said problem. It's really the pair of problems. But then I would stay in the teens. So the second problem might be 13 minus 10 minus 9. And this next set might be 17 minus 10 minus 9. And then I might end with 15 minus 10 minus 8.
Yeah.
Just for that little bit of at the end where it's not too formulaic, but you got kids really thinking. And in a big way, it's not about getting kids, I am learning a strategy. It is, first grade kids will be thinking about what is it from a teen minus a 10. Teen minus a 10, that's that number hanging around, right? 17 minus 10 is 7. 16 minus 10 is 6. Like that's part of the meaning of teens. So we're building that. We're building a sense of place value a little bit in the teens. And we're helping kids think about the over strategy. What happens if you back up too much? So yeah, there's that. That's what it could look like in first grade.
Can I interrupt you to say that, like,
Sure.
when you do that teen and then you subtract the 9, the problems that you just named that were the yuckier problems are yucky. Like they are some
they're
funky
often missed.
ones.
Often missed problems.
Yeah. And so first graders getting to experience that. It's pretty great.
It's nice. Yeah. And in a problem string, they're getting experience where they get their answer confirmed, checked often. Like you could go send kids off to do that many problems and they can do them all wrong and not get good feedback. But they're getting feedback because they're doing them all together. Okay.
Yeah.
Second grade. I'd probably keep the first two pairs of problems. So 16 minus 10 minus 9, 37 minus 20 minus 19. But then I'm going to stay in the 2 digits, sort of under 100. So then I might do 52 minus 30, 52 minus 28. Here I'm going to change it up. It's not 29, 28. Then I might do 83 minus 50. Notice that's a big jump. 83 minus 50. That's a big old, they're thinking about that. And then 83 minus 47. So tweaking that last problem again, but also it's not just, if you look over the whole string, it was minus 10, then minus 20, then minus 30, then minus 50. The next problem string I might do minus 40, minus 20, minus 30, minus 60, but kind of staying in the 100.
Yeah. Yeah. Nice. So in third grade, I might do one pair that's like 37 minus 20, 37 minus 19 that we had in there. And then jump to the 462 minus 100 minus 95. Those are nice starter. But like you, I'm going to hang longer in the like hundreds. So maybe 546 minus 200 and then minus 198. And then like you, the jumping up from the big jump, a next nice pair might be 813 minus 500 and minus 497. So you're spending a lot of time in the hundreds, which is, a lot of the bulk of third grade. But then we go back. We go back to one of the problems, which was the thousands. So 6,371 minus 2,000 and minus 1998. So the first problem is like a little entry and the last problem is a stretch, but the majority of it is in the hundreds.
Nice.
We talked about this and we agreed that for fourth and up, we would just pick all the problems from the middle for this particular string. So starting with the 462 minus 100 minus 95, the 6,371 minus 2,000 and minus 1988 into those two pairs of decimals, 5.2 minus 2 and minus 1.9, 2.63 minus 1 minus 97 cents, and then into that stretch of a fraction problem. Though that, we just cut off a little at the top and at the bottom. And then with adults, you mentioned the problems that you would do. We did the adultish string, but you left off some of the helpers when you were talking about it. So again, same thing. Do the stretch of the problems with adults, but leave off the helpers unless they're necessary. Like as you're facilitating and you see the need for them, you could put them back in, but the aim would be not to.
And even though you just said on the last one, adults, I think that the fourth and up in the adults, really, it's pretty much the string that we did here on the podcast, where you're then making judgment calls about when do you ask for a helper problem? When do you say, anybody guess the next problem? You're trying to keep everybody kind of challenged enough and everybody's secure enough in what's kind of going on.
Yeah.
And then you're taking note, how did kids deal with the decimals? How did they do with the fractions? Are they able to think about 2,000 or some numbers in the thousands minus 1,000, or, and they're practicing rounding and estimation and reasonableness, and they're getting a sense of what it means to subtract a bit too much and then add it back in. And if you're in middle school, you could do some work with subtracting. That when you do that, you're sort of like, let me use one of the problems: 462 minus. Well, actually, let me use an easier one: 37 minus 20, and then when you did 37 minus 19, you're kind of doing 37 minus 20 minus 1. So if I do 37 minus the quantity 20 minus 1, and then I distribute that negative, you end up with 37 minus 20 plus 1.
Yeah.
So there's some nice work that you can do making sense of distributing that negative and, sort of an algebraic feel for what's happening. So lots of good work can kind of happen at the upper grades while you're helping kids build the numeracy that maybe they didn't have a chance to build younger. Yeah, nice. Hey, y'all, we're going to write this up. We've been asked so much for this kind of thing that we're going to write this up and put it in our blog. So mathisfigureoutable.com. I think it's /blog, but if you just Google mathisfigureoutable.com or mathisfigureoutable blog, you'll get there. And then just check out the blog that we're putting out right about the time that this podcast comes out. And you'll see, I know we went through these numbers kind of fast, but we'll kind of write it up so you can kind of get a feel for what it would look like to take an adultish string and kind of make it fit for different grade levels and why.
Yeah.
All right, y'all. Thanks for tuning in and teaching more and more real math. To find out more about the Math is Figureoutable movement, visit mathisfigureoutable.com. Let's keep spreading the word that math is figureoutable.